My name is Ilić, and I'm a PhD student at the Faculty of Mechanical Engineering, Department of Naval Architecture. My presentation today will be about the global response of hull structure ultimate strength based on progressive collapse analysis of one typical inland waterway vessel. Through this slide, you can take a look of a little overview of the presentation. Already at the beginning, we have to wonder why is this type of approach necessary? Why is this type of analysis necessary for inland waterway vessels? Technical standards for large seagoing vessels like bulk carriers and oil tankers already incorporate this kind of analysis within their regulations. Ultimate strength assessment of other ships is also addressed in the rules of the classification societies. But however, there are no corresponding procedures of ultimate strength assessment for the inland waterway vessels. And the target of this presentation is to make a little step to provide to transfer practice of seagoing of ultimate strength assessment for seagoing vessel to inland waterway vessel, and to provide some benchmark calculations. For decades, the structural assessment of ships' hull girder is performed in the elastic domain of the stress strain curve. That means that the safety margin is considered till yielding, but not for the overall collapse. But once in a lifetime, ships could undergo some extreme events which can cause some catastrophic failure, like this snow today. We didn't expect it, but it's happened from time to time. In this photo, you can see one accident, one ship which has been broken in two 1.5 months ago. This accident happened at the coast of the Black Sea, and this was river sea vessel, which means that it can operate also in the river and the sea area near to the coast. By the dimension of the ship, we can see that it is a typical dimension for river vessel. And year of the build told to us that, of course, ship was old and it's questionable in which condition it was at the time of the accident. Of course, this can be caused by some excessive bending moments due to extreme waves or some other unpredicted loading conditions in the design phase. Now, what is the ultimate clean state of the inland vessel, or the vessel? The ultimate strength is is the bending moment in the vertical plane, because that is assumed as the most dominant load for the inland waterway vessel. In this lateral view of the ship, you can see two types of the loading conditions, sagging and hogging. Sagging is the type of the bending moment in which the elements above the neutral axis elements on the top of the deck basically are in compression, while the elements below the neutral axis on the bottom are yielding. Hogging is a vice versa situation. Of course, if some extreme bending moment is applied to the ship hull girder, elements which is under the compression will progressively undergo to collapse, but elements on the opposite side, on the bottom side, will yield following the nonlinear stress strain curve. Analyzed methods in this paper was mainly on the progressive collapse analysis which is incorporated by the International Association of Classification Societies. Is one document named Construction Rules, mainly for the seagoing vessel. The second one is Pike-Mansour method, and the last two methods for fast and quick estimation are first yield and first collapse. Now, procedure for progressive collapse analysis. First we have to divide hull cross section into the following segments. There are three types of segments: plate, hard corner, and the stiffener with attached plates. The second step is to define the relationship between stress and strain for each of segments. Third step is to initialize the curvature. That is the first incremental step. Fourth step is to calculate for each of the segment corresponding strain and corresponding stress. And in the end, in each of the increment, we have to calculate the vertical bending moment by this formula. And now we have to estimate what is the ultimate limit, what is the ultimate moment. That is point of that is the point with the slope of the vertical bending moment curvature diagram becomes negative. Pike-Masur method. Analogically speaking, Pike-Masur is pretty much similar like progressive collapse analysis, but simplified. Starting from the deck, elements will collapse along the height of the cross section. On the other side of the neutral axis of the cross section, on the bottom, elements are assumed to yield. From the bottom to the neutral axis, we have a linear distribution of the stress. And the point when the forces from the opposite side of the neutral axis are equal, that is the moment when we reach the ultimate moment. Now simplified methods, first field and first collapse. It is the minimum moments of the most vulnerable segments of the bottom and of the decks. And this was the analyzed vessel in this paper. Like you can see, this is a vessel you can occasionally see in the Danube Rhine River. The type is chemical tanker, and this is the literal view of the general arrangement and the middle section of the ship. And we'll make a little comparison between the ratio of dimension of the sea going versus the river ships. And we pick up one middle range sea-going ship with a length of the 274 meters and the height of 52 meters. We can see that ratio of this dimension is 4 times smaller than in comparison with the river vessel. And regarding to buckling, that can be in some situation fatal for the ship if ship reach the ultimate moment. Now we come to the calculation, basically to the time when you will see curvatures. If we take a look of the curve which represent the progressive collapse analysis for sagging and coiling situation, you can see that curves are linear till the moment when the collapse of the deck and bottom elements was starting. And now, of course, you can see the point when the slope becomes negative. That is the moment when the moment is in the maximum phase. We will better see it result in the last slide with the numbers. Like we conclude in the paper, my previous thought, the most dominant phenomenon governing the ultimate strength of the Ilić waterway hull is buckling. The difference between progressive collapse analysis and Pike-Masur method was 3% in sagging and 20% for coiling. Pike-Masur method is sensitive to segment division and sensitive to segment division in the position of the neutral axis. That is the reason, because the results can vary. The first collapse bending moment based on the collapse of just bottom and deck elements showed more than 2 times lower values of the ultimate hull capacity. And that is normal because we choose the most vulnerable segments of the deck and of the bottom. The first yield moments are larger in both conditions. And for sea-going vessel, the situation is different. First will happen the first yield, and then ship will reach the ultimate strength. Like I told on some of the first slides in the design phase, criteria are based on the yielding, not on the overall collapse, which is dominantly governed by the buckling of the segment. And that can be a main message for this presentation, that rules and regulations for inland vessels have to consider that option to take into account the larger safety margin. Thank you for attention.